Hey guys, wanted to do a video of extra inverse practice of all function types and kind of lead you into what next week's new material will be like at the end. But when it comes to functions, a lot of times we've been thinking about to find the inverse, reversing the operation in the order and the actual operation itself. So for example, and I'll show you another way that we can do it too. Example here we have y equals 3x minus 7. If you were going to plug a number in, like say 2, the first thing you would do is multiply by 3 and then minus 7. Well, when you do that, to find the inverse, we're going to go the opposite way and the opposite operation. So I'd add 7 and divide by 3. So again, if you plug in 2, you get 6 minus 7, out comes negative 1. We know that when you plug in this x value, here comes this y value. Well, if I found the correct inverse, and by going backwards, that would probably make me think I'm going to add 7 and then divide all of that by 3. So this should be my inverse function. Now if I try it, that means I plug in this as the new x. It's y, but now it's x. Negative 1 plus 7 is 6, divided by 3 is 2, and that does output. What was x now is our y. So since the x input becomes the y output of the inverse, to find an inverse you can actually rewrite the function up here, but flip the x and the y first, and then solve for y all by itself. So if I want to get y alone, my first step would be to add 7. So I'll have x plus 7 equals 3y, and then divide by 3 to get y alone. And looky there, x plus 7 over 3 is our inverse. So let's try the other linear one down here. We could talk about how first you would multiply by negative 4, and then add 2, and then divide by 8. So we know we'd reverse those, but let's try solving with the flipping of the x and y first. So we'd have x equals negative 4y plus 2 all over 8. To cancel out dividing by 8, we would multiply by 8 on both sides. So I'll come over here, that'd give us 8x equals a negative 4y plus 2. To get rid of the 2, we'd subtract it from both sides, so 8x minus 2 equals 4y. And then finally, dividing by 4, make sure you divide the whole thing by 4. We'd have y equals 8x minus 2 all over 4. We could reduce that, but for now, let's just validate that it does, instead of divide by 8, multiply by 8 first. Then instead of adding 2, it would subtract 2. Instead of multiplying by negative 4, we should be, dividing by negative 4. Got that one, but there we go. That would be our correct inverse. So note how you can flip the x and the y and solve for y again, and you have your inverse, but it also follows the rule where we reverse and do the opposite operation. Moving on to quadratics. We've got any kind of parabola. We remember we'd have to limit the domain, but let's assume all domains are properly limited and we would find the inverse. I'm going to do this one the old school way. First we would square it, and then we would multiply by 3, and then we would subtract 7. So my inverse is going to be take my x value and add 7, and then divide by 3. Instead of squaring, I will square root all of that, and that should be our inverse. This one, I'll go ahead and try it the other way, where I flip the x and the y first. So I'd have 4 times y minus 2 quantity squared. And my goal now is to get y alone. So what am I going to rip off first here? I'm going to do, again, order of operations in reverse. So normally how I would subtract 2, then square, then times by 4, I'm going to divide by 4 first. So I'd have x over 4 equals y minus 2 quantity squared. So instead of squaring, I will square root both sides. So I've got square root of x over 4. Sorry, that square root needs to go over the whole thing. Equals y minus 2, and my last step would be to add 2 to both sides. So I've got my final answer to be y equals square root of x over 4, all quantity plus 2. It does matter where the square root is. Notice how it is not over the 2. But again, we would want to make sure that we have that add 2 on the outside. Okay, this little guy down here, I have scrunched myself. Just a second here. Okay, nothing like scrunching yourself here, but Remember, first we would take a number divided by 3 first, and then we would square root, and then we would add 5. So to reverse that, I'm going to do x, subtract 5 first. Instead of square rooting, I will square that, and then I'm going to, instead of divide by 3, multiply by 3. So this should be my inverse. Again, we could always plug in a number for x and see what the output is, and then we could, so like try 3. 3 divided by 3 is 1. Square rooted is 1 plus 5 is 6. If I put 6 in here, 6 minus 5 is 1. Squared is 1 times 3 is 3. It does check out. That's a couple quadratics for you. Here's an inverse function. These are our favorite. Remember, I honestly think the best way to do this would be just to say, well, remember the inverse of 5 over x? Is 5 over x. You can just use that. But I will show you that if you switch the x's and the y's, this one's kind of tedious. You'd multiply by y first, and then you'd have yx equals 5. To get rid of y alone, you'd divide by x. And looky there, it matches. Down here, I'm going to show that I would first, remember the add 7 thing? I can show you how if you flip the x and the y here, but again, it's a little tedious. I call it the Birkeland theorem. I'll show you that in a second here. Oops, sorry. Okay, you'd have y plus 7. Okay, so to get rid of the y, this one, you have to go multiply by y plus 7 on both sides. So when you have y plus 7 times x, you've got x times y plus 7 equals 3. To get the y alone, you'd want to divide by x here. So you'd have y plus 7 equals 3 over x, and then you want to minus 7 at the end. So your inverse is 3 over x minus 7. But if you were in class, remember how when we saw this one, if you have this guy underneath, you like kick him out and change the sign? That's the same thing. So also, like if you had your original function was 3 over x plus 9, your inverse would be 3 over x minus 9. So I like to just use this one as a pattern. If it's underneath, kick it out. If it's out, kick it under, but change the sign. But now you see the work to solve it and how it would solve out with x and y switching. All right, cube root. Oh, first I would add 2, then cube, then times by negative 5. So add 2, cube, and then multiply by negative 5. So I'm going to take my x and divide by negative 5, and then cube root, and then instead of add 2, I would subtract 2. So there's my inverse. Right here, again, I'll switch my x and my y on this one for you. First thing I'm going to do is divide by 2. So I have x over 2 equals cube root of y plus 7. Now to get rid of the cube root, I'm going to cube everything. So I'd have x over 2 cubed equals y plus 7. And then subtract 7 on both sides. So my inverse will be x over 2 quantity cubed minus 7. That would be my inverse for a cubic. All right, and finally, a little bit of leading you into where we're headed next week for a lesson. You'll get a handout and probably another video, plus there's some videos on my website already. Think about this one, 4 to the x. When you plug in a number on this, like 1, you get 4. 2, you get 16. 3, you get 64, I think. Right? So we want a table where if we had an inverse, you would plug in 4 and get 1. Plug in 16, you get 2. Plug in 64, you get 3. Can you think of any functions that when you plug in these large numbers, you get these answers here? It's not just square rooting. I want you to be thinking about that. Also think about the graph of 4 to the x looks like. It's going to be something like this. Remember, the inverse would have to be kind of like that because it reflects over the y equals x line. So something to think about. Of course, then the other thing you would be doing is taking 4 to the y. What do we do when we want to get y out of the power? Cliffhanger. Google it, check it out, come back for more. I'll get you a worksheet and there'll be videos for you. Hope you enjoyed some inverse practice. It'll help you on the quiz and good stuff to know for now and for pre-calc. See you soon.